and open up to the next available page in your notebook and put today's date. And then today we're going to be looking at topic 3, lesson 6, which is generate equivalent expressions. So go ahead and title your notes. And then remember, during the video, feel free to pause or rewind as needed. That way, if I'm moving too fast, you have a little bit more time. So we're going to start with just a definition of what equivalent expressions are. We've talked about expressions, both numerical and algebraic expressions, and basically we're talking about problems that have, or expressions or phrases that have numbers on operations, and if it's an algebraic expression, it also has variables. So equivalent expressions they're kind of what you would expect when you see the word equivalent. And they're going to be expressions that have the same value when solved, but they look different. So you can write down their expressions that have the same value when solved, but look different. So we're going to be using properties of operations in order to generate equivalent expressions. Some of these properties you've probably already used before, but you maybe didn't name them the specific name that they have. And so they may seem kind of familiar. So we can go ahead and title this part Properties of Operations. And these properties are going to help us quite a bit when we're doing things like solving equations because they allow us to manipulate the expression or equation to kind of do what we want. So the first property is called the commutative property. And there's the commutative property of addition, and there's the commutative property of multiplication. So these two properties do not work with subtraction or division. So let's start with the commutative property of addition. This property basically says that if you are just adding numbers together, you can reorder them. You can change the order, you still get the same answer. So if we were to write that using variables, that would mean that if we have two numbers a and b, and we have a plus b, that's the same thing as if we have b plus a. And that's probably something you already knew, but maybe you didn't know is called the commutative property of addition. So for example, 3 plus 5 is the same as 5 plus 3. Same thing goes for multiplication. So if I were to multiply a times b, I could get the same answer or the same result by multiplying b times a. Okay, the second property we're going to look at is called the associative property. And again, this works with addition and multiplication, but not subtraction or division. So the associative property has to do with grouping numbers together. So for example, if we have two numbers that we're adding, a plus b, and those are grouped together, and then we're adding on c, that's the same thing as if we grouped together the b and the c. So we could add a and b first and then add on c, or we could add b and c first and then add on a, and you get the same exact answer. Same thing goes for multiplication. So if I group together a times b and then multiply by c, that's the same thing as grouping together b times c and then multiplying by a. The last property we're going to look at is the one we're going to focus on the most, and that's the distributive property. So the distributive property we have across addition and subtraction. So it's the only one that really deals with subtraction. And basically what this property says is if you have a number and you're multiplying it by the sum of two other numbers, instead of first adding B and C together and then multiplying by A, you can actually distribute the A by multiplying it by each term inside the parentheses. So I could rewrite this as A times the first term B plus A times the second term C. And this works for both addition and subtraction. So instead, if I had B minus C, I would have the same thing. I'd multiply A and B. I'd multiply A and C, but this time I would subtract their values. So that's what we're going to focus on is the distributive property. So let's take a closer look at this. And we're going to start with just using numbers, no variables, and we're going to look at the example 9 times 87. So we're going to talk about three ways where we could use, or three strategies we could use to solve this problem. The first strategy is called partitioning. So partitioning is where we kind of break the problem up and make it into easier problems. So instead of just doing 9 times 87, sometimes what people do is they say, well, instead of 87, I could treat that as 80 and make that a little bit more mental math and multiply it by 9. And then I could take my other 7 that I have and also multiply that by 9 and add those two products together. So this makes it more mental math. So 80 times 9 would give us 720. 7 times 9 would give us 63. And then we can just add those together to get 783. So that's partitioning. That's one strategy to make this a little bit more mental math. Another strategy is using an area model, and we're going to use this quite a bit. So the area model uses a rectangle and the concept of area to find the total. So if I want to find the area of a rectangle, if you think back to how you do that, you just multiply the length times the width. And so what I'm going to do is I'm going to use these numbers as my length and my width. So I'm going to take that smaller number, put it off to the side here, and then instead of putting 87 up here, I'm going to break it down into easier numbers. So a lot of times numbers that are multiples of 10 are good to use. So I can think of this as 80 plus 7. And so I'm going to separate this into two rectangles. One has a length and width of 9 and 80, and the other one 9 and 7. And so now I can just multiply their length times their width. So 9 times 80 is 720. And then the length and width of the smaller one would be 9 times 7, which is 63. And then I just need to add those two together, which again gives us 783. So that's using the area model. And then lastly, we're going to use the distributive property. So the distributive property we'll put over here. So I'm going to take 9 times 87, and again, I'm going to break apart 87 into easier numbers. So 80 plus 7. And then I'm going to distribute the 9 to each term inside the parentheses. So instead of adding 80 and 7 and then multiplying by 9, I'm going to multiply the 9 times each term on the inside, and then I'll add them together. So I'll start with 9 times 80. and then I'll add on 9 times 7. So 9 times 80 is 720. 9 times 7 is 63. That would equal 783. So you'll notice all three of these strategies, you're pretty much doing the same thing. It's kind of depending on how you look at it. For all of them, though, you end up adding 720 plus 63. So what we're going to do now is look at some examples, and we're going to use both the area model and the distributive property to kind of compare them. So I'm going to turn over to the next page. And we'll label this examples. And so now we're going to look at some examples that have variables. So for example 1, we're going to start with the expression 5 times the quantity r minus 3. And what we want to do is use the distributive property to come up with an equivalent expression. So I'm going to start by using the area model. So I'm going to draw my rectangle. And just like before, the number outside the parentheses I'm going to drop down right here. And then r minus 3 will go up top. Since there's 2 terms, I'm going to need 2 rectangles. So to find the area of the first rectangle, I need to multiply the length times the width, so 5 times r. And 5 times r we just write as 5r. For the smaller rectangle, the length and the width is 5 and 3, so I'll multiply 5 times 3, which is 15. So I can rewrite this as 5r minus 15. Okay, so that's using the area model. Now we can go to using just the distributive property. So if I go back to the original expression, 5 times the quantity, r minus 3, I'm basically just going to distribute the 5 to each term inside the parentheses. So I'm going to multiply 5 times r, which would be 5r, bring down my subtraction, and then multiply 5 times 3, which would be 15. And so you can see we get the same answer either way. And so it's equivalent to 5r minus 15. Now you can't actually subtract these because one term has a variable and the other doesn't. You have to have the same variable if you want to combine them. It's kind of like if I have one pen and I have one pencil, I can't combine them and say I have 2 pens, right? I have to keep them separate. So same thing here, since I have a variable and then just a constant, you cannot combine those. All right, let's look at a second example. Okay, so for example 2, we have it's negative 8 times the quantity 2y plus 4. So let's start with the area model. So I'm going to draw my rectangle, bring down my negative 8, and then 2y plus 4 will go up top. Since there are 2 terms, I need 2 rectangles. And so for the first rectangle, I'd multiply length times width, so that'd be negative 8 times 2y. So negative 8 times 2 is negative 16, and then I have my variable y. Over here, I have a length and width of negative 8 and 4, so I'm going to multiply negative 8 times 4, which is negative 32. So we end up with negative 16y plus negative 32. Now let's use the distributive property to do the same thing. So I have my original expression, negative 8 times the quantity 2y plus 4. And so I'm going to distribute the negative 8. So negative 8 times 2y plus negative 8 times 4. And I'm going to simplify this. So negative 8 times 2 is negative 16, and then I'll bring down my y, plus negative 8 times 4 is negative 32. Okay, so we get the same simplified expression either way. which is equivalent to what we started with. Okay, let's look at one last example. Okay, so for number 3, we have the expression 6 times the quantity, and then in brackets, 3a plus negative 2b minus 1. So I'm going to start with my area model. And I'll bring down the 6. And then my terms are 3a plus negative 2b minus 1. So this time I have 1, 2, 3 terms, so I need 3 rectangles. Right, and then I just need to find the area, so length times width. So here I have 6 times 3a. 6 times 3 is 18, and then I'll bring down my variable. For the middle rectangle, I have the length and width of 6 and negative 2b. So 6 times negative 2b. 6 times negative 2 is negative 12, and then I'll bring down my variable. And then lastly, I have 6 and 1, so 6 times 1 is just 6. So to write out my expression, I have 18a plus negative 12b minus 6. I can't combine any of those because they either don't all have a variable or they have different variables. So that is my simplified expression. Okay, and lastly, let's do the same thing but with the distributive property. So I'm just rewriting the problem. And now I can distribute the 6. So I've got 6 times 3a plus 6 times negative 2b minus 6 times 1. Okay, so I can work each of those out now. 6 times 3 is 18, and I'll bring down my variable, plus 6 times negative 2 is negative 12. I'll bring down the b, and then minus 6 times 1, which is 6. So again, we get the exact same expression, but just a different way. So our original expression is equivalent to 18a plus negative 12b minus 6. Okay, so the big idea here is we want to make sure we're able to use these properties, and we're really focusing on the distributive property at the moment. And that's really going to help us when we are simplifying and when we're solving equations.